Today we will be working on lesson 4.5, and it's all going to be about graphing radical functions and radical inequalities. So we're going to start by graphing different forms of radical functions on the same graph so you can see what type of transformation is happening. Now this video is going to be for my pre-AP. Even though you do see a calculator here on the side, it's there only to verify our work, but remember you have to do all the work on your own without a calculator. And I'm going to be showing you both ways, because usually a test is a non-calculator test, but a QCA, you are allowed to use a calculator on the QCA. So it's good to know both methods. Now let's start with the first, number 1. Graph the following function, and you're supposed to use a different color for each graph. So I'm going to start with the black, and this is going to be for the first one. So I'm going to start on that, number 1. Make some room to write the table. Now I'm going to put an x and a y, and if x is 0, square root of x is 0. If x is 1, so what I'm doing is I'm plugging in the value of x in here to find what y is. So square root of 0 is 0, square root of 1 is 1. I'm going to use numbers that would be easy for me to figure out. So square root of 4 is 2 and square root of 9 is 3. So this is going to be my parent function, and keep it in mind. Now let's graph it. 0, 0, so I'm going to use the same color. So 0, 0, black would be my parent function. So keep in mind that this is going to be your parent function. So 0, 0, and then the other one is 1, 1. Then 4, 2. Then 9, 3. So this is going to be my radical function or square root function. As you can see, it looks like a shooting star. It always have an endpoint, and this is the endpoint of this shooting star, this square root function. Now to know what the domain is, the domain, as you can see, it's from the endpoint all the way to the right, so from 0 to infinity. And the range also is going to be from my endpoint all the way up. As you can see, this continue on forever, so it's going to be all the way up to plus infinity. So let's write this down. The range is going to be 0 to infinity. Now for the number 2, I'm going to be choosing the red. Now y equals 2 square root of x, as you can see. So I'm always going to start with my parent function, which is 0, 0, 1, 1, 4, 2, 9, 3. Now you might remember this from previous. So as you can see, it's multiplied by 2, so you multiply the y by 2. So 0 times 2 is 0, 1 times 2 is 2, 2 times 2 is 4, 3 times 2 is 6. So now this is going to be your x, and this is going to be your new y. So let's graph that. So 0, 0, let me make it smaller. I'm going to use the same color, which is red. So 0, 0, it's the same now. Now 1, 2, 4, 4, 9, 6. So as you can see, it also looks like a shooting star with this endpoint. So it's also from, domain is going to be from the endpoint, which is 0 all the way to infinity, since it's going all the way to the right. And the range is going to be also from 0 from the endpoint all the way up, so to plus infinity. So that's going to be my domain and range. Now let's look at number 3. Remember so this is going to be in blue. Y equals to negative radical x. So I'm going to use the same. I'm going to always start with my parent function. Does it ring a bell? So always start with your parent function. 0, 0, 1, 1, 4, 2, 9, 3. We did this for quadratic equation and linear functions. It's the same concept. Now negative, it means the y is going to be negative now, so it's going to be 0, negative 1, negative 2, negative 3. So this is going to be my x, and this is going to be my new y. And now I'm going to graph it in blue. So 0, 0 is going to be here. Then you have 1, negative 1, 4, negative 2, 9, negative 3, and then you graph it. Now as you can see, it has the same endpoint, but it's going to be reflected. Now the domain is from the starting point, and since it's going to go to the right, so from 0 to infinity, since 0, 0 is my starting point, as you can see over here. Now the range is going to be, since it's from the end point, and since it's going to go down, as you can see, going to go on forever down, so it's going to be from 0 to negative infinity, so write them in order, negative infinity to 0. Now let's move on to the next one. If you'd like, you can pause the video and try 4 and 5 on your own, if you remember how to do it, and then play the video to check your answer. So I'm going to use a different color now. Let me use the green. So make some space. So also start with the parent function, xy, so 0, 0, 1, 1, 2, 4, 2, 9, 3. And since you're adding a 4, and inside the parentheses, remember, since inside the radical, it's going to be opposite, remember? So it means has to be done to the x, and you are subtracting a 4. So under the radical, the change is done to the x, and it's opposite. So if it's a plus 4, it means you minus 4 from the x, because it's going to go to the left, remember? If it's a minus 4, then you have to add a 4 to the x. It means it's going to go to the right. So now you have to subtract a 4 from x. So 0 minus 4 is going to be negative 4. 1 minus 4 is going to be negative 3. 4 minus 4 is going to be a 0. And 9 minus 4 is going to be a 5. So this is going to be my new x, and the y, I did no change to it. So my points are going to be negative 4, 0. So this is going to be my starting, or you can say end point. Negative 3, 1. 0, 2. And 5, 3. So this is going to be my point for my graph. Again, it's a shooting star in green. So all of them has been shooting star except number 3, which is being reflected. So let's do number 5 now. Choose a different color and choose the purple. So again, you start with the parent function xy, 0, 0, 1, 1, 4, 2, 9, 3. So plus 4, it means this is done, since it's outside the radical, so the change is done to the y, and it's the same, so you add 4. So 0 plus 4 is a 4, 1 plus 4 is a 5, 2 plus 4 is 6, 3 plus 4 is a 7. So this is going to be my x, it's the same, and this is going to be my new y. So let's graph that. So 0, 4, this is going to be my starting point. 1, 5, or end point, usually they say end point. 4, 6, and 9, 7. So as you can see, it also looks like a shooting star. And for the domain and range, I forgot to do the one for number 4. So let's look at the domain. The domain is going to be from the starting point, which is a negative 4. And since it's going to go to the right, so I'm going to write it over here. So domain is going to be from the starting point, which is a negative 4. And since it's going to go to the right, so that's an infinity. The range is also going to be from the starting point, which is negative 4, 0. So the y of the starting point is a 0. And since it's going to go up, so 0 to plus infinity. So as you can see, it's always good to tell what your starting point is. In this case, it's negative 4, 0. So the domain is going to be from negative 4 to infinity, since it's going to go to the right. And the range is going to be from the start point, which is a 0, all the way up to plus infinity. So it's always good to realize what your end point is. So you can say end point or starting point. Let's use end point from now on. So domain, also let's decide what our end point is. It's a 0, 4. Let's see that. It's 0, 4. So its domain has to do with the x. So from 0 to infinity, since it's going to go to the right. And the range is going to be from the y of the endpoint, so from 4, and since it's going to go up, so to infinity. So that is 1 through 5. So what I want you to do, I want you to go through 1 and through 5 and check them. Ask yourself, It's always been to infinity. The domain has always been to infinity, and the range has always been to infinity. Only one time the range was from negative infinity to a number, and this is in number 3 when it was reflected. In all the other cases, it's always been to infinity. So keep in mind, whenever it's reflected, it means that the range is going to be from a negative infinity to a point. Now, let's move on to this. What trends or rules can you determine based on these graphs? Y equals to a square root of x minus h plus k. I'm going to write some examples. For example, what if you have a 2 square root of x minus 2 plus 1? What if you have, for example, half or negative half into x plus 3 minus 2, let's say. So the a, which is this one, usually tells you whether it's going to compress or stretch. And if it's a negative, it's going to tell you whether it's going to be reflected or not. The h, which is the number with the x under the radical, like a negative 2 and a 3, is going to tell you whether it's going to go right or left. And the k is going to tell you whether it's going to go up or down. Remember? Now, it would be a good time to pause the video and do the next example on your own. But before you do that, let's do some of the examples together. Which of the above variables, or questions, which of the above variables control the starting point of the domain? So let's look at the starting point of the domain. For example, let's look over here. The starting point of the domain was in -4. So probably it's the h, which is inside the radical, and it's the opposite. It gives me my domain, the starting point of my domain, or the what should I write for the domain. Now, as for the range, as you can see, there's nothing on the outside of the radical. That's a 0. And over here, there's nothing inside the x. There's no h. That's why the domain is a 0. There's a 4 on the outside. That's why the range starts with a 4. Now let's look at the other examples. There's no h. That's why the domain starts with a 0. There's no k. That's why it starts with a 0. So let's answer those questions. Which of the above variables control the starting point of the domain? Usually it's the h, which is inside. So the h, which is inside the radical. Which of the above variables control the starting point of the range? So x minus h plus k, usually the k tell me the starting point of my range. So that's the k. Now pause the video and try the table on your own. I hope you tried on your own, so let's do this together. Now, is this going to be shifted? Yes, since the -2, so it's going to be shifted down by 2. Reflected, no, there's no negative on the outside. Since we have a 2, a is a 2, so this is going to be a stretch, a vertical stretch by a factor of 2. Now here, is it going to be reflected? Yes. How is it going to move? It's going to move left by 2 and up by 2. Remember, opposite of the h and the same as k. Effect of a, so half, so it's going to be a vertical compress or shrink by a factor of half. Now in the other examples, they gave you the changes and you're supposed to write down the equation. So vertical stretch by 3, so that's a 3. There's a reflection, so a negative. Shift down, there's no right or left, so there's only x under the radical. Down, so -5 outside the radical. Now vertical shrink by a factor of half, so a half. No reflection, so it's a plus, it's not a minus. Square root of right 2, so it's going to be x minus 2. And down 4, so it means -4 on the outside. That is your equation, f of x equal to this number. Now go ahead, try 6 and 7 on the back sheet on your own, and then there should be another video showing you that and the inequalities. Good luck.